Today we're going to look at making this CuMai copper and Damascus Sgain-Dubh. Alright, let's jump right in. Step one is to make the Damascus. We're going to make 18 layers of 15 and 20 and 1084. I'm using thicker layers of 1084 so I can get a little bit more darkness in the blade. But when I squish it out, you'll see it comes out pretty even. I'll weld up the ends, and I don't really care that I'm using a stick because I'm going to cut it off. But when I do the center seam to stop the billet from spreading apart as it heats up, I'm going to use the MIG welder without any filler. I'm just going to simply melt it together on the edge so I don't have to grind it off later. If you do like these, help me out by hitting that like and subscribe button. I'm going to throw it in the forge, but we ended up with a problem today. There is a windstorm outside with winds reaching 60-70 miles per hour. And what happens is the power goes out as I'm heating up the billet. I was really worried that with the billet heated up to about 1200 degrees and then the power going out, my ribbon burner forge has to shut down because there's no air blowing. I didn't know if I just ruined the billet or not. When the power came on, I pressed forward and started reheating and setting the welds again, but I took a little bit more time setting those welds. It turned out there wasn't much oxidation there because it did work in the end. With the welds set, it's time to draw out this billet. There's a lot more steel than I need here for a 4-inch knife, but this is actually going to be the steel for 3 different knives that I'm making. So we'll cut a little bit off at the end. With the steel drawn out, time to just clean it up, cut it up, restack it, and back in the forge. I do have to admit, if you're making some tools, a surface grinder attachment for your 2x72 is a great tool to have. We'll cut up our bar in 5 sections to give us 90 layers. When we put this all together, we're going to have 90 layers on each side, plus the center steel, plus the copper. So we'll have 180 layers of Damascus in total. Throw this new billet back in the fire, draw it out, and now we have a long bar of 90 layer Damascus. The CuMai billet's going to consist of our Damascus that we just made 90 layers, a center core of 1084, and then another 90 layer Damascus on the other side. In between all of that, we're going to use 2 pieces of copper. It's 0.4 millimeter copper that I'm using, and we'll clean it all up and get it welded together. We're going to weld up all sides of this. We need to completely seal it so that the copper won't melt and run out of the billet. They're not the prettiest welds, but I've completely sealed up all of the seams so we have an airtight billet. I'll toss it back in the forge. It's small enough I'm just going to use tongs, so I'm not putting a handle on this one. And I'm really going to watch my temperatures. I want to make sure I don't liquefy that copper, but I want to make it soft enough that it actually brazes to the 1084 and the Damascus. Ideally, I'm looking to keep the temperatures between 18 and 1900 degrees. I'll again do a quick pass to set the copper weld, if you can call it that, and then we'll start drawing it out. Once the bar is flat, I'm actually going to use the drawing dies rather aggressively in about 1/2-inch increments. That's what's going to give me that nice wavy pattern. Now I ran into a problem here. I was hoping to make enough steel for 2 knives. I ended up only getting 1 out of it because, as you can see, the steel is curving due to the press. I should have been more careful, and I wasn't. What happened when I tried to straighten it out was half of the billet delaminated along the copper. So we end up with another hunk of steel for the scrap pile. So much for 2 knives out of this billet. We do have enough for the Sgain-Dubh, so we'll cut that off. And because this is CuMai, we can't forge it to shape without it delaminating just like it did. So we'll actually cut it to shape as well. Because I'm worried about heat treating this because it's such a small blade and the shock of quenching tearing apart that copper and steel, I'm going to leave it a little bit big, heat treat it, and then grind it to final shape. For heat treating, we'll start off with normalization. I'm going to do 3 normalization cycles at 1600, 15 and 25, and 1425. I find, especially with Damascus and CuMai, heat treatment will give you that nice dark edge. If you don't heat treat properly, you're going to get something that's a little bit soft in color. For quenching, I add about 15 degrees. That way, when it cools off between transferring from the kiln to the quench oil, it should be at my target temperature. The oil is preheated to approximately 400 degrees, and I do that simply by quenching a block of mild steel that I've got kicking around. When I grind my CuMai, I don't actually mark a center line. What I do is grind each side, trying to keep that 1084 in the middle of the blade. It's kind of a de facto center line, but I'm really looking to make sure I have 1084 for the entirety of the length of the billet. If I have to take a little bit more off of one side or another, that's the way I'll balance it out. With the blade in its final shape, it's now on to my favorite part, etching. So, into the ferric chloric acid, sulfuric acid, and distilled water. If you want to know how I make this solution, I'll put a link in the description. As well, I've got a number of videos on how I fully do this etch. It's a lot of back and forth, 3 minutes at a time with light sanding up to 3000 grit in between. A blade this nice needs something special for the handle and sheath. So I'm going to use this buffalo horn that has a gold discoloring to it. I'm going to try and match up. I've got 6 pieces of it, and I'm going to try and bookend match a couple of these so they look like they actually go together. It's a little bit of a puzzle, but I think I came up with 4 of the 6 that seem to actually fit seamlessly together. Next step is to literally grind out where the tang goes, add a couple pins, and then start grinding out the sheath portion. I never thought of this when I was doing it, but grinding and sanding natural materials stinks. There's just no way around it. So get some ventilation if you do this. I should have anticipated this problem. I now need a pinhole in the tang of this 60 HRC handle, and of course a drill bit isn't going to cut it. The way I solve this problem is I use the mill and a carbide down cutting end mill. It's slow going, but it does make its way through. It's just expensive, and quite often it's pretty easy to break a bit. Okay, time to put this thing together. One of the first things we have to do though is I'm really worried about epoxy squeezing into the sheath when I glue it together. So I'm going to coat, almost literally fill this cavity with Vaseline. I want to get it everywhere so that if epoxy does squeeze into the cavity for the sheath, it's only going to stick to the Vaseline, which is going to fall out. So I'm going to coat everything thoroughly with Vaseline. I'll give the epoxy a few minutes to set up till it's kind of that soft tackiness, and then I'm going to use a saw blade to scrape out as much of the Vaseline and any apparent epoxy that may have squeezed in. Trim off some of the excess, trial fit, and it works. With everything glued up, it was back to the 2x72 to shape the rest of this handle. Now I discovered something about buffalo horn. All of those gorgeous markings, they don't run all the way through the horn. Sometimes they're deep, sometimes they're not. So I had to make a choice. I was starting to sand off some of the markings, and I really wanted them there. It It really adds a lot to the blade. So I chose to keep it a little bit thicker than I normally would have, but I think it was worth it in the end to keep those nice gold flashes. I took the sanding right up to 800 grit, and I'll warn you, it ruins belts. The horn gets into everything and it stinks to high heaven when you're doing it. Now it's time to put on the touch mark and the copper pieces. I used to electro etch my touch mark. Since buying this 20-watt fiber laser, I now laser in my touch mark and any other markings that I may need. For the Mason symbol and the Ram Grotto symbol, I'm going to laser them into some copper, and then I'm actually going to use the laser to cut the circular shape, because I'll never sand it or cut it perfectly circular. It takes a long time for a 20-watt laser, though, to cut through 0.4 millimeters of copper. It took nearly 30 minutes doing multiple passes to actually cut 95% of the way through the copper. I did that so it would almost be like a punch out. And you can see on the back, it almost goes all the way through. I used the cutoff piece of the buffalo horn to run a test on how to burn in the indent for mounting the discs. I did find out that if you run your laser too hot, it will start a fire. Buffalo horn burns. So I had to really tone it down. I did 175 passes at low power to get these nice indents into the horn to fit the copper pieces. Last step was to use the laser to cut the ram's head in half so that half would go on the sheath, half on the handle. Glue it all together and it's ready for any piper to tuck in his sock.